in mechanical engineering in August 2001 from Mumbai University. He has done his PhD in material science from VNIT, Nagpur. Sir has got a teaching experience of 33 years. As far as membership of his professional bodies and scientific bodies are concerned, he is a life member of IST, that is Indian Society for Technical Education. He is life member of ISNT, IET member, SAE India member, and a very active member, I would say, in the SAE Western region. He is from a Quality Circle Forum of Indian membership member. His research interest includes, in which he has delivered expert talks also, that is IC engine, engine design development, engine emission, design modification, BS4 engines, modern emission technology, then automotive design technology, vehicle design, electric vehicle design and development. These are some of the areas in which he has his expertise and has delivered expert talks on this. Uh, he has been technical judge and reviewer and editorial board member for various national international conferences and journal. Around 37 of them are there. As far as his expert lectures are concerned, he has delivered more than 24 FDP and STTP lectures and has conducted more than 10 courses and coordinated them. Sir has got around 48 publications to his name. As far as achievements are concerned, Sir has received Best Technical Paper Award at Indian Institute of Foundrymen. He has received SA India Guru Award 2016-17. He is a governing board member of SA India Western Section, PhD supervisor in Mumbai University, and worked as judges in different technical events level, national and international conference. So this was a brief introduction about Umale sir. Many more are there, but I would not take that time. Sir will speak for himself. Yes, definitely. We are looking forward for getting knowledge from you, sir, in the topic that you are delivering today. So over to you, Umale sir.
Sir, my PPT is visible.
Yes, sir.
Yes, sir. Yes.
Okay. Good afternoon, all the participants and organizers. Today's topic is vehicle dynamics in electric vehicle perspectives. Now I am working as a head mechanical engineering department, Sardar Patel College of Engineering, Andheri, Mumbai. I have given my email ID if you want some questions. If you have questions and further informations you want, you can note down my email ID, Umale Sudhakar @gmail.com. I learned this vehicle dynamics from my guru, Thomas Gillespie, USA. I attended his 5 days complete workshop with my 15 students of SE racing car. I was the faculty in charge of from 2007 till now. Just I got the my post as a head of department. I left the faculty advisors. This Gillespie written book as Fundamentals of Vehicle Dynamics. So this is a very good book. I have the contents in my seminar. It is from this book, Fundamentals of Vehicle Dynamics by Thomas Gillespie. You heard about this book, I think. When we want knowledge of this vehicle dynamics, you must know what is the meaning of vehicle dynamics, what is the concept of it. Vehicle dynamics Mukul. Can I मुकुल हे कर्सर कुठे येतो तो मार्करचा बंद केला मी व्हिडिओ पेन What is the meaning of vehicle dynamics? Vehicle dynamics is dynamics of vehicle in motion. A second definition is it is a study of how the vehicle will react to driver inputs on given solid surface. The subject of vehicle dynamics is concerned with the movements of vehicles. Now this is very important. What is the movement of vehicles, particularly in all vehicles, all automobiles, trucks, buses and special purpose vehicles on road surfaces. The moments of interest. Now I will concentrate on acceleration, braking, ride and turning. So what is the effect of these four quantity on the vehicle movements? And hence we will discuss the vehicle behavior when we have different forces on the vehicles, and these forces are available at the tires. It is come from gravity and aerodynamics. Okay, so this gravity is the actual weight W. This is a tires resistance and aerodynamic resistance. We will discuss now one by one. Vehicle dynamics generally depends on three modules. This is a power module. It indicates the source of power. It may be engine or it may be electric vehicle or it may be anything. Chassis module. Chassis is required for supporting the vehicle, and body, that is a cover of the vehicle, is called as the body of the vehicle. And hence we will discuss what is the effect of power module on vehicle dynamics, what is the effect of chassis design on vehicle dynamics, what is the effect of body module on vehicle dynamics. So you must know what is the power module. Power is obtained from engine or electric motor of vehicle, and it is transmitted to different wheels through transmission system. A selection of engine or electric motor. So I will cover both IC engine vehicle as well as electric motor vehicle, that is EV. You can understand both. This power module depends on power generation by IC engine, power generation by electric motor, and this type of engine or type of electric motor you have to decide. And hence the source of energy, once you decide the source of energy as engine or electric motor, we have to do the further calculations. And the engine location or electric motor location is very important, how it is connected to the wheel. In between the engine or in between the electric motor, how it is connected to wheel, it has so many components in between that. In case of IC engine vehicles, we have transmission of power from clutch to gearbox, propeller, shaft, universal joint and differential and rear axle, and lastly to the wheel. Similarly, power transmission in electric motor is done through the reduction gear, means that is the drive systems, electric motor to drive system to the wheels. And in this way we have the different components for drive system in electric vehicles. And the location of electric vehicle, electric motor in electric vehicle is very important. Similarly, I will explain first for IC engine vehicle. The location of engine is very important, whether it is on front side, whether it is on midseat, or whether it is of rear of the vehicle. Similarly, electric motor location is very important, whether it is at the front position, whether it is at the middle of the vehicle, whether it is at the rear of the vehicle. Depending on position, the vehicle dynamics is decided, and chassis can be designed. We have to discuss main, that is the layout of vehicles. And generally we have the front mounted engines are very popular. Similarly, the motors which are placed, it is generally in the driver side. It is very popular in electric vehicles. What is the difference between selection of power module in case of IC engine vehicles? I have given these two types when we are using IC engines, and what is the vehicle dynamics when we are using the electric motor, and what is the vehicle dynamics. So generally in case of IC engine, weight and position of engine is very important. Similarly, in case of electric motor vehicles, weight and position of electric motor is very important. What is the weight? Therefore, we are using the lightweight electric motor for design of the vehicle. And position of electric motor. So where it is at the front or in middle or at the rear. In case of ICE engine, where is the engine, whether it is in the front, middle or rear. This is the main difference. Now in case of electric vehicle, where it is placed electric motor position and how it is connected to the wheel, it is very important. And we have the calculations of forces from electric motor to the wheels. And hence how the total engine weight is calculated in case of ICE engines vehicles, that is the total weight of the engines plus fuel tank. Because fuel tank has some weight, it is added into the total weight of the vehicle, and hence before designing of the chassis or before calculation, you must know the total weight of the vehicles, that is engine plus fuel tank in case of ICE engines. But in case of electric vehicles, you must know the electric motor weight, you must know to the battery pack. Battery pack is required in case of electric motor. Electric batteries is the source for energy for electric motor, and hence battery pack weight is very important. So this is the system of power transmission in case of ICE engine to the transmission systems and transmission system to the wheels. In case of electric vehicle, the motions are transmitted from motor to the transmission, that is drive trains, and through drive trains to the wheels. This is the mechanism. This is the difference of vehicle dynamics in case of ICE engine and in case of electric motor vehicles. Now we'll discuss after this power module, we'll discuss the chassis module, how this chassis is designed for both ICE engine as well as electric vehicles. So generally how the chassis is designed, it is completely designed according to the complete operating unit. We have different operating unit in that it has some motions. According to this motion, chassis is designed. It includes so many parts. In case of ICE engines, we have so many parts. That is the frame, suspension systems, steering system, axles, springs, shock absorbers, engine, clutch, gearbox, propeller shaft, differentials, steering, brakes, accelerator, fuel tank, storage battery, radiator, silencer, tires and wheels. In case of electric vehicles, some of the parts are deleted here. That is in the vehicles we have the frame, we have the suspension system, we have the steering systems, we have the axles, we have the springs for supports, we have the shock absorbers. Only engine is not available. Instead of engines we are using electric motor. Clutch is not required. We have the rotating control systems. We have instead of gearbox we have the reduction gear systems. We have the propeller shaft, or it may have a drive line in case of electric vehicle instead of propeller shaft. We have the differentials to convert motion or given power to the wheels, driving wheels. We have the steering wheels. Driver is controlled the motion of the vehicle by steering wheel, that is called as steering systems. We have the brakes to control the vehicles. We have the controlling systems in case of electric vehicles. Instead of accelerator, instead of fuel tank, we have the battery packages, and instead of radiator we have the cooling systems. In case of electric motors, electric motor must be cooled, and hence we have the cooling system. Cooling system has some weights, again it is added to the total weight. There is no silencer in case of electric vehicles. We require the tires as well as wheels, and hence in case of electric vehicles, design depends on motor locations. Okay, this motor location is very important. We will discuss what is the effect of motor locations on vehicle dynamics. Effect of battery pack locations on vehicle dynamics, effects of drive line on the vehicle dynamics. So we will have 3 points for electric vehicles. First is the motor locations, second is the battery pack location, third is the drive line locations. We'll discuss one by one all. Third module is the body modules. Generally, vehicle dynamics depends on vehicle body. So, why this vehicle body is related to the vehicle dynamics? Because aerodynamic forces are decided by the vehicle body. The portion which is available, front portion which is available, which is very important for aerodynamic forces, and hence when we discuss the automobiles or vehicles, we have different types of fronts. So this is the fronts of vehicles. We have different fronts of vehicles, and according to the fronts of the vehicles, we have different types of aerodynamic forces. We'll discuss how these aerodynamic forces will develop in the vehicles. So, and hence body modules, body design is very important for vehicles. Now, how this body is very important for the vehicles. Not only we can avoid the aerodynamic forces, but we require also body, and hence body which is required for main thing is for comfort. So this vehicle body first it is designed for comfort of the comfort for the passengers, protections to the passengers, and good look. So these are the three two important decisions we take during design of vehicle body. And according to the vehicle body, we have the aerodynamic forces on the surfaces of vehicles. So comfort is necessary, protection of the passenger is necessary, good look of the vehicle is very necessary, and hence a body may be decided according to for a new concept. We have the aerodynamic forces, and hence when we say the body of the car, let us say this is a car. This car has three portions. First portion is called as electric motor compartments or engine compartment. Second is called as a passenger compartment, and third is called as a luggage compartment. All three compartments are required during design of the vehicles, and how to keep this electric motor or engine, it is decided by the manufacturer of the vehicle, and hence all the vehicles are designed for more space for the occupants or passengers, and it this luggage compartments is also important, and hence other components are required for the safety as well as comfort, that is bumpers. Bumpers are very important for vehicles. It again it has some weights, the fenders, radiator grills in case of ICE engines, protection for electric motor. We require the hood, interior trim, glass, and paints. We are the important parameters we require during body design. A wide variety of body styles. So some vehicles has 2 doors, some vehicle has 4 doors. We have sedans, hot top vehicles, convertible vehicles, station wagons. So every vehicle has different vehicle body, and it is vehicle body is very important for designs. So when we have a 2 doors, the compartment space is now this is the compartment. We have door on this side, a driver side, passenger doors on the back side, front door, second doors, and in this way we require the maximum space, and hence we require the more and more doors for the vehicle body. And hence vehicle design point of view, we have so many designs. The modern automobiles can be categorized into two distinct sub-assemblies. We have the different types of sub-assemblies, a body of the vehicle, and according to the body of the vehicle, we have the different sub-assemblies. Second is sub-assemblies we have for the chassis design. So we will discuss the sub-assemblies for that. How to design the chassis? Chassis is most important for the vehicle design. Now I will just take the chassis design according to the vehicle dynamics point of view, not others. And hence, when we want to design the chassis according to the vehicle dynamics point of view, the designer must know the automobile layout. And what is the automobile layout? We'll discuss later on. So what is automobile layout? Layout is just like length, breadth, and height of the vehicles. So you have to decide the total length of the vehicle, total width of the vehicle, total height of the vehicle, and hence according to that chassis is designed. And the layout is mainly decided by the locations of the engines or electric motor and driven wheels. So when vehicles have two axles, particularly when we have the front axle and rear axles, this distance between two axles are very important for layout, and this is distance width. This is the distance between. Here we have the front portion, here we have the rear portions of the vehicles, and we have three divisions. This division, distance between axles, and lastly for the luggage, and hence this layout is very important. And different types of layouts we have for different types of vehicles. Now I have to explain, I want to explain the truck layout. What is the truck layout? Now this is the truck layout. I have written here vehicle dynamics depends on truck layout, where electric motor is placed in the layout, where engine is placed in the layout. Now this is the Tata Telco truck. Now this is the axle, this is the rear axle, front axles, this is the top view of vehicles. We have the wheel track. Wheel track is very important. What is understanding of wheel track? Then wheel base, you must know the wheel base distance. This is the distance between the centers of the two wheels. This is the distance of the center of the axles. Wheel track is the center of the axles. In between we have different components required for the power transmissions, and hence according to the different movable components, vehicle dynamics are decided. According to this is the very important divisions. For each vehicle we have different calculations of vehicle dynamics, and hence you must know the various types of two-wheeler vehicle dynamics is different, three-wheeler vehicle dynamics is different, four-wheeler vehicle dynamics is different, truck dynamics, buses dynamics, car dynamics, and hence we have different vehicle dynamics portions. Here it is not possible to discuss all. I will discuss the overall vehicle dynamics for four-wheelers, particularly passenger car. Now vehicle dynamics depends on, already we have discussed that vehicle dynamics depends on the vehicle layout, and vehicle layout totally depends on drive arrangement, how the power is transmitted from the source of power, that is electric motor, to the wheel. Let us say we have the rear wheel drive. The power is transmitted to the rear wheel. Here, in case of rear wheel drive vehicles, power is transmitted to the rear wheel, and what is the location of engine or electric motor to give the power, and in between that we have the power transmission systems. This rear wheel drive again designing for hill climbing. Why it is very important? We get the grips for that. During hill climbing and acceleration provisions, we get the good traction. We get the good tractions when the drive system is rear wheel drive. So this is the one of the advantage of rear wheel drive during hill climbing and when we are providing the maximum acceleration. And this again rear wheel drive can be divided into two groups: front engine rear wheel drive, or front motor rear wheel drive. The motor is placed or engine is placed front, and the power is transmitted to the rear wheel. But another type, that electric motor or engine can be placed at the rear side, and the power is transmitted on the rear side, and hence it is shortly known as rear engine or rear wheel drive, or rear engine front engine rear wheel drive, or rear engine rear wheel drive. So we have so many advantages and disadvantages of rear wheel drive. Already I have explained advantages. rear wheels acts driving wheels. So in case of rear wheels, only power is transmitted to the rear wheels, not to the front wheels. And only front wheels are used for steering purpose. The steering is connected to the front wheels, and we give the directions to the wheels. What are the drawbacks of this rear wheel drive? We have the long transmission systems. We have the losses of power in this case. Requires more number of components in case of this, because we have the longer distance. Rear axles, if it is like that, you will require the number of components to drive the motion from front to the rear side. Passenger compartment floor is formed to accommodate the propeller shaft, and hence this space is required for passenger, and passenger space is very important during design of vehicles. Front wheel drive vehicles, we have the power is transmitted to the front wheel, and engine may be at the front wheel, and this is the means there are no components in between this. Only we have the electric motor or engine at the front, as well as axle is also at the front, where we want to transmit the power very close, and no components are required. This front wheel drive is having some again advantages and disadvantages. When we are using the front wheel drive, it provides more space for rear passengers, because we don't have any components this side. We can use more space for passengers. The front wheels are used for steering only, as well as for driving force. This is again, we have the addition of driving force to the front wheel. In case of rear wheel drive, only front wheels are used for steering, but in case of front wheel drive, the front wheels are used for steering purpose as well as driving purpose. And hence, what is the main feature for this? This improve vehicle handling, particularly in slippery conditions. This is very important. How to control the vehicle during slippery positions. In case where the driver steering effort becomes excessive in the car, we can use the power assisted steering systems always. Now, generally, many vehicles, off-road vehicles, are of four-wheel drive. The power is transmitted to all four wheels. Power is transmitted to all four wheels. Now, this 1, 2, 3, 4 like this. So that we will get the power is torque is transmitted to all, and hence during heavy loads we require more torque, and there is no problem with this four-wheel drive vehicles. Generally, it is preferred in case of off-road vehicles. These are the advantages of four-wheel drive vehicle. Drive is very safe. Drive is very safe because the distribution of the drive to all four wheels. The sharing of the load between four wheels, it is again very important. During acceleration, the risk of wheel spin is reduced, particularly in the snow area or during the mud conditions. So let us say we have the rear wheel drive, and if it is in the mud, we cannot have the power transmissions. So it will slip, and this front wheel is only rotating because of the as it is fixed in the mud. We have the only rotations, and vehicle will not move in the forward directions. During design, according to the vehicle dynamics, we have the vehicle assemblies. I will only discuss only some important vehicle assemblies which are related to the vehicle dynamics. So we have 6 basic assemblies in the vehicle. First is engine or electric motor vehicle assemblies, running gear or basic structures, driving system assembly, basic control system assembly, electrical system assembly, accessories. I will take only this and basic control system, which is very related to the vehicle dynamics. What is meant by running gear or basic structures? So running gear means it is not only gearbox. There is a understanding that running gear means only gearbox. It is not like that. Running gear includes all important parts of the systems, start from frame, suspension systems, springs, shock absorbers, wheels, rims and tires, and hence these components are very important for controlling the vehicles, and hence we are considering all important components like frame, suspensions, springs, shock absorbers, wheels, rims and tires during consideration of vehicle dynamics. So second important is the how to control the vehicle. Control of the vehicle is very important. When we are using all these components, if the this tire is not connected with the road during bumping, during whenever we have the speed breaker, vehicle will bump on the top side. That is called as bumping of the vehicle, and this tire cannot be connected to the road, and driver cannot be controlled. Means there is no control of vehicle because the tire is not connected with the road surfaces. And again, this is very difficult controlling of the vehicle when the skidding begins in the vehicles. And these are the two important conditions of vehicle dynamics: how to control the vehicle when tire is not touching to the contact roads, as well as whenever there is a skiddings. Now there is a role of suspension. There is role of suspension in the vehicle dynamics, as it is the basic structure of the vehicle. Now, what is the function of suspension? The tire always touching to the surface in all road conditions. Okay, so road conditions, whenever road condition is very bad, the suspension systems involved in the controlling the vehicles. The suspension system is having another advantage, and it requires a very strong suspension system we require to resist the twisting of these axles or twisting of components. Because of twisting, sometimes components may break because of the heavy torque of the engine or heavy torque of the motor, and hence what is the role of suspension system we'll discuss later on. Suspension system has very important role in controlling of the vehicle dynamics. Then this frame design is very important according to the vehicle dynamics conditions. The frame is designed, and it is the rigid structures that form the skeleton to hold all major units together. Here units means is the components. During vehicle dynamics, these all components movements are considered, and all movable components are fitted in the rigid structure called as a frame. Particularly the wheels and tires are very important. So how this wheel structure and tire assemblies are connected to the frame. The wheel is connected and tires are connected to the frame, and it is very important for suspension systems. So we have two types of suspensions. We require the suspension for front wheels, as well as we require the suspensions for rear wheels. And we have two types of suspensions: independent suspension systems and dependent suspension systems. It has relative advantages and relative disadvantages. And why we require the suspension system? Because road is not regular, and for the irregularities of the road surfaces we require the suspension systems, and it is fitted in the frame, and frame is the most important component we design. Now, what are the basic control systems? Basic control systems, we have two types of basic control system. First is the steering systems. First is the steering systems. Driver is controlled the vehicle through steering systems, and hence it is the first basic control system in the vehicle. Second is braking systems. So again, driver is controlling the vehicle through brakes, and hence these are the two systems: steering systems and braking systems are called as basic control systems of the vehicles. and hence these steering efforts. Now the driver is giving some efforts to the steering wheel, and it should be control, and driver control is very important, and hence we require for the modifications or multiplication of this gear rotations through gear ratio of steering wheels, and the direction of this wheel is very important in case of steering of wheels. What is the direction of motion and turning? During turning, we are using generally very effectively steering wheels. What is the use of brake system? So whenever we want a slow down of the speed of the vehicle, the brake system is applied, and or we want to stop the vehicles, it depends on the driver's wheels. When driver wants to stop the vehicle, he applied the brake system, and is particularly brake, and you must know the braking system and effects of braking system on the vehicle dynamics. And entire brake system is located in the chassis, and brakes are mounted inside the wheels. And now vehicle design parameters are very important. Vehicle design parameters are very important. So I will discuss these vehicle design parameters according to the vehicle dynamics point of view. So there are some parameters designer must think on. So whenever designer of the vehicle wants to design vehicle, he must concentrate on maximum acceleration. What is the maximum acceleration of the vehicle? What is the speed of the vehicle? That is the speed range. He must know the speed range of the vehicle, economical speed of the vehicle, economical design of the vehicle, load of the vehicle. Now, what is the particularly different trucks? So whenever truck is loaded, we have the different load. When empty truck, we have the different load. And hence load of the vehicle. According to the load of the vehicle, we have to consider the vehicle dynamics. Ride is very important. So we want during ride comfort is very important. We'll discuss later on what is ride comfort. So this ride comfort, what are the components, what are the factors to be decided, it is very important. Handling characteristics, how to handle the vehicle for maintaining the comfort as well as safety of the occupants or passengers, and hence handling depends on vehicle dynamics. Size of the vehicle, it is very important how to decide the size of the vehicles. We have so many sizes of the vehicles in the market. So vehicle drag. So vehicle drag is very important. It is nothing but the force. Now I want to define the what is vehicle drag force. So vehicle drag force is very important for vehicle dynamics. Vehicle drag is a force which resists motion. So, okay. Vehicle resistance of motion is very important. Vehicle drag is a force which resists motion and is due to the deformation of the wheel. It is deformation of the wheel or tire and the ground. So this is let us say this is our tire, and let us this is the ground, and there is a deformation of this tire because of the load, and then this deformation as the deformation increases, there is a resistance of the motion, and hence we will discuss later on what is the resistance of motion, what is the vehicle drag, what is the deformation of the wheel or tire with the ground, what is the aerodynamic effect. Because of this is the first reason. This is the first reason of the vehicle drag because of the reduction in vehicle speed. Second reason is the aerodynamic effect, that is a force. This is aerodynamic force which has some action on this body which reduces the vehicle speed. So we'll discuss one by one. So these are the parameters to be discussed during design of vehicles according to the vehicle dynamics point of view. Now this is a very fundamental question to the designer. What are the fundamental requirements of vehicle? How vehicles are designed considering the vehicle dynamics? So these are the fundamental considerations. So just you observe that first concept of design of vehicles. Safety of the occupant is very important. So because passenger is very important. So passenger is very important. The vehicle is not so important. passenger is important, and hence how to provide the safety to occupants during motion of the vehicles, and hence we have to design the vehicles in such a point of view. What is the dynamics for safety of occupants? Vehicles are designed to carry the people. Vehicles are designed to carry the people very safely. Okay, this is our motto of design. Vehicles are carried to carry people with safety. Okay, we'll discuss later on. Comfort of the vehicle. So, second fundamental requirements of design of vehicle is comfort of vehicle. So, what is exactly comfort of the vehicle? So, during driving, according to the driver's wheels, according to the driver wheels. So, driver is giving some commands to the vehicles. Means vehicle has to listen the driver commands. This is very important. How the vehicle has listening all these driver commands. Let us say driver is giving a command as stop the vehicle. How this vehicle will stop when driver applies the brake. So the applying brake is one command to the this. So during giving the command, driver must know comfort of the vehicle. So let us say during applying sudden brake, driver this passenger will disturb. Let us say one of the disturbance is suppose driver has not applied the brakes whenever there is a speed breakers, and there is a bumping of the vehicles, and driver will not controlling the vehicles, and we have the and we are losing the comforts of the passenger or occupants, and hence how to give the proper comforts to the occupants, that depends on the driver conditions, and hence the vehicle has to listen the vehicle. It is very important. We'll discuss later on that. During this vehicle dynamics, we have a third point. So behavior of vehicle during turning. So that is called as cornering. Let us say this is a straight drive. This is a straight drive. Vehicle is moving with straight, and suddenly driver wants to change his direction. That is called as turning. During turning, you know that there is a shifting of passenger. Passenger is not stationary. Passenger having some vibration. A passenger will move, or luggage will move from one place to another, and we have to consider these movements. Sudden turning is very difficult, safety point of view, and hence behavior of vehicle. What is the vehicle dynamics weighing when we are at the turning points? During cornering, we will discuss. So safety point of view, always you must know what are the driver's commands on the vehicles during turning. So what do you mean by characteristics of comfort? Always the vehicle designs, vehicles are designed according to the characteristics of the comfort. So you must answer yourself. You must answer yourself how you characterize the comforts. We have different types of comforts according to the passenger conditions, and you are providing all that. So one is called as luxurious comfort, and which is economical, let us say coldness, which is provided by the AC. But how to give the comfort according to the vehicle dynamics, that is the stationary conditions. In all conditions, driver must be very steady. According to the driver conditions, when driver is changing the directions, the left direction, right directions, sudden braking, sudden accelerations, the passenger will lose his comfort condition. That is, passenger is not steady. He is vibrating. He is changing his positions according to different driver conditions given to the vehicles. And hence, what is the comforts according to the comfort level, and hence according to the passenger's point of view, comforts can be decided, and it can be defined according to the comfort level. So this economy is very important. Economy is very important. That is called as economics of vehicle dynamics. How do you provide the some economical conditions during motion of the vehicles? Okay, so fixed. Always we require the we have the steady state conditions and transient conditions of the passengers when the or drivers on the or the vehicles. Steady in the steady state conditions, passengers are steady. They are not vibrating, or they are not moving during running conditions, and you are providing these conditions. Let us say we are providing the very powerful suspension systems, very imported or very safely designed tires that absorb the shock, which are transmitting from the ground to the vehicles. And hence economical design may be considered for the vehicle dynamics point of view, so that comfort can be maintained for the passengers. This is our mechanism for vehicle dynamics design, how the vehicles are designed according to the vehicle dynamics concerned. So driver is very important during vehicle dynamics concerned. So driver is giving command to the vehicles. Let us say command is more acceleration. Driver is giving command is braking command, accelerating command, deaccelerating command, sudden braking. And hence driver vehicle has to listen all driver's actions. Driver is giving some command, that is called as action. Driver action is compulsory on the vehicle conditions, and vehicle is giving responses. Vehicle is giving responses according to the driver's will. Driver will is very important. So what is the vehicle response? So this vehicle response is very important, vehicle dynamics of point of view. Again, if there is a irregular response, whenever there is a irregular response of the vehicle, let us say we have the vibration of the vehicle, we have the lot of turning, disturbing turning or disturbing cornering. So sudden deaccelerations. So again, this response, we have the provision. This response, bad response should be given to the driver, and hence driver can be controlled. That is called as a directional stability. How to control the directional stability we will discuss later on. And this effect, responses effect, is given directly or indirectly to the. Now, what is the effect of these responses? It may be a good response or it may be bad response, and both responses are given to the occupants. Both responses, good response as well as bad responses, that is called as effect, and this effect is very important for the occupants. Okay, let us say there is a sudden braking. The driver is suppose driver has applied sudden braking, and what is the condition of occupants? So driver is occupants is moving suddenly, and he may be passenger may be damaged, and he will occur some accidents during this uncontrolled situations. And hence during design of the vehicles we have to develop some mathematical models, and hence we have the subjects according to the Gillespie, that is fundamentals of vehicle dynamics when you discuss. So we have to develop the vehicle models. So that is through mathematical models. We have the mathematical models. We have to derive the equations for this mathematical model. I will not take these different types of equations, but I will concentrate it on inputs. What are the inputs of the these models? And when you are providing some inputs, definitely we are getting the output. So we get the good outputs for this, and then so we have the mathematical models. So development of mathematical models has some conditions how to develop the mathematical models, and before developing these conditions, the designer must know the conditions of these vehicles. What is the condition? That is during design of this mass of the vehicle is very important. So mass of the vehicle is very important input to the mathematical model. What is the mass? Truck mass is different, passenger car mass is different, motorcycle mass is different. And we have the moment of inertia. We have during calculations of these forces. We must know what is moment of inertia along the axis. Along x-axis we have I-axis moment of inertia along y-axis, I-y-y. Along z-axis, we have the moment of inertia I-z-z. Now we have the internal forces as well as external forces. External forces cannot be controlled. So always these external forces like aerodynamic forces cannot be controlled by the driver. It depends on the body of the vehicles or wind velocity. This wind velocity is very important. So this wind velocity creates wind forces. This on both sides. Wind forces on both sides. Let us say this is a vehicle. This wind forces acting on this front when vehicle is moving with this velocity. This force, wind force, can be acting on the front direction, lateral direction, always. Okay, left side, right side, and it can be considered. This aerodynamic force or wind forces can be considered for this mathematical model as an input to the vehicle. And effect of this vehicle body on the aerodynamic forces we have to consider during giving the input. So which vehicle body is very important for reducing the aerodynamic forces, and hence passenger cars are designed for lesser aerodynamic forces, and hence according to the lesser aerodynamic forces we have the body vehicle body designs. Now steepness, what is the steepness is very important for in design of vehicles. Steepness, that is the input to the model, mathematical model. So steepness can be considered from springs which are used for suspension systems, shock absorbers or for suspension systems. Damping which is reduces vibrational motions. What is a suspension stiffness? What is the spring stiffness? What is damping value? And we are having so many sources of forces. What are the different forces acting on the vehicle? It is very important. And how to add, how it is added, how the individual forces are added on the vehicle body, or if it is interior of the vehicle, how this interior forces like rolling resistance or any other internal force which are acting on the vehicle. So that may be the input of the mathematical models. And other than this we have other inputs which are applied by the these are the natural, these are the natural inputs which are required. Now according to the driver conditions, we have the different types of inputs. What are the different types of inputs given by the driver for mathematical model? So there is a steering behavior, steering. He is operating the steering, and hence he are providing the steering angles. Acceleration, accelerator means he is operating accelerator, so he must know what is the accelerator positions. Here acceleration is the process. According to that, acceleration is given to the vehicle through acceleration pedal. Deaccelerations by braking. So deacceleration, sir, now the speed is reducing when we are applying the brakes. That is a deacceleration, may be the input. A sudden braking, if the driver is applying sudden brake, it is also the input to the vehicles. Maneuvering, so during driving, your driver has to control the vehicle, and hence condition of maneuvering is very important. Changing of lane is very important. Let us say we have the road, this is the road, and driver, we have the different types of vehicles. Now this is a vehicle, another vehicle, and this is our vehicle. Driver wants to change his lane. The driver wants to have changing its lane. So driver is changing this lane to this lane. Okay. So during that conditions we have the different vehicle dynamics, and that is called as dynamics during the changing lane. So this may be the one of the input to the vehicle dynamics. Overtaking. So generally driver, when the front vehicle, this is the front vehicle to this vehicle. When the front vehicle is very slow, driver wants to move this vehicle with high speed, and therefore he wants to change his lane. So overtaking, this overtaking is very important. So there are two types of change in lane, that is called a single lane change. I will define what is a single lane change. Let us say this is our vehicle. Now the driver wants to change the this vehicle. This is the vehicle. Now this is called a single lane change. This is called a single lane change. Again, suddenly, because of the front vehicle, driver wants to go, and the driver wants to change his lane. Again, he wants to come this direction. So now this is the first change in lane, and again driver wants to change this direction in the same previous, and this is called as a double lane change. So during that period, again driver is giving some inputs to vehicles. This is for first lane change. Again, driver wants to change his lane, and called as double lane change. And this vehicle behavior is understood when you understand this is ISO 8855 or DIN 7000 we have. So that gives the parameter of vehicle behavior. So now this ISO parameters, this is international terms they have given, ISO 8855 or DIN 7000. According to this, it defines the principal terms used for load vehicle dynamics condition. When you want to understand principal terms which are used for the road vehicle dynamic conditions, you must go through the ISO standards. And how this, just I want to explain how this ISO standards are applying for the passenger cars, buses, and commercial vehicles. So these ISO standards for vehicle dynamics are applicable for passenger cars, buses, commercial vehicles, and it is also applied to the one or more steered axles or multi-axles also vehicles, or in combination of all. So multi-axles, two axles vehicles, or we can apply this. So that go through the ISO standard for this, and you can understand the conditions given for the vehicle dynamics. Now, when we give the output, I have given these conditions. When you give the output, now I have given all inputs to the vehicles. Now I want to observe what is the output of the when I want to apply inputs. Definitely, I will get the output of this. What are the outputs I get? Now distance covered. I want more velocity. I want more accelerations. That is the speed. Speed is the output. Speed is the output of this. So I want to check all these behavior, because I want to change this output according to the passenger conditions. So during output conditions, whether driver has checked the comfort level, it is very important. Whether driver has observed the feeling of the occupants or passengers. If the passengers are observing the bad feelings during driving, no, sir, some drivers are driving very roughly. What is the reaction of the occupants or passengers? It is very important. They are giving bad feeling. If they are giving the bad feeling, so outputs are not good. If the driver is not driving very safely, and hence this is not a good objective. This is not good output. And hence these are the three levels of outputs according to the passenger comfort level conditions. First is distance covered by the vehicle. It is called as a speed. Okay, so vehicle can be traveled by different speed. Let us say 100 km per hour, or it may be 200 km per hour, like this. This is the speed, and hence this speed can be observing by the vehicle conditions, vehicle dynamics conditions, and this is very important. Every time there is a grip of the tire with the road, otherwise the driver will lose his control on the vehicle. So this grip is very important. This grip of the tire with the road always important during observing the vehicle dynamics conditions. Now, during design of the vehicles, we have so many types of conditions. So, what type of tires we are using? Tire is very important. We are now in modern tires. Now in the modern tires, we are using the viscoelastic materials. So let us say we are using the rubber. We are using the only rubber. That is, the rubber has the property as elastic behavior. When the tire has only one property, that is elastic behavior, so it acts as a spring. So it is now this is it gives the now this is a spring. The tire acts as a spring when the what is the tire condition? Tire conditions is elastic. So tire is behaving the elastic conditions, and hence it is just giving the stiffness, and hence it is a spring. The spring gives the stiffness. And when we are only using the damping, viscous behavior. Now when we are using the now this is related to this. So this is one of the model, the spring model. So this spring model we have when we have the rubber. So now what is the visco material? It has two. It has both viscous as well as rubber. Let us say we have designed the tire in such a way that it has only viscous behavior. Only viscous behavior means it is just like a dashpot. Now this dashpot is denoted as like this. And this dashpot which indicates the damper, which this is denoted as damper as C. This damper as C, which absorb the shock, and hence we have different types of circuits of this material. So when it is rubber, we have only this like this. When we have only damping, we have the like this. When we have the combination of for the viscoelastic material, we have the like this. This is the circuit for this. When we have now this is parallel, means KE and dampers are parallel. When it is in series, when stiffness and damping condition on series, we are showing is that. Sometimes we are using the pneumatic tires. Sometimes we are using the rubber tires. So during rubber has generally these conditions. So let us say there is a friction. There is lot of friction during traveling conditions. Now there is a symbol for friction. There is a symbol for friction like this. So it is one of the symbol. So it may be friction element. And this can be shown like this. So let us say when we have the no damping in the tire, so and only we have the elastic condition and friction conditions, then this may be the control like this. So this may be the circuit diagram for this. Okay, this may be the circuit diagram for this. So but we are using the viscoelastic material. It is one of the best material for the tires. It is nothing but rubber, and rubber is having two property. One is elastic property. Second is called as the viscous property. Elastic property depends on time and frequency. So I will not explain what is the effect of time on the elastic condition. What is the effect of frequency on elastic conditions? It is very time consuming, and hence I will not explain here. Otherwise, it is very important. There is a question generally people will ask, why tire is developed for rolling resistance. So because tires are designed for time conditions as well as frequency conditions. So according to the viscous conditions, according to the spring conditions, and that is called as the driving dynamics. How you drive the vehicles, that is called as driving dynamics. Straight line dynamics. So we have four types of dynamics. That is the straight line tracking. So what is the straight line tracking? It gives information regarding path tracking controlled by the dynamic simulations of vehicle vehicle straight line motions. So we are using the different softwares for calculation of all these dynamics. So we have the simulations softwares. Second is the maneuverability. So during maneuverability, generally passenger is observing load shifts. So now let us say in the buses, in the bus, this is our bus. Now this is a passenger. This is the passenger one, and driver is changing his path like this. Now what will happen? Passenger is also changing his position unnecessarily, and hence it is called as now this passenger will change. Load is also changing its positions, and this is called as unconditional load shifts, and it is undesirable. So this is not desirable conditions. It is not required actually. Passenger shift is not required during maneuverability, and hence driver must understand what is the safety of driving. Self-steer behavior. Self-steer behavior. What it gives? It gives the idea about driving stability. Always we remember. So driver must know what is the driving stability. We'll discuss later on what is driving stability. What is driving steering control? Always driving must know the what is driving steering control. So he must know the driving steering control. We have some factors for it. We will discuss later on. So generally we have these two conditions. Generally people will ask what do you mean by directional stability and what do you mean by loss of directional control. So we'll discuss directional stability later on, and loss of directional control. So driver must concentrate on directional stability as well as loss of directional control, and hence during driving dynamics, so these types of stability we require, that is driving stability condition, driving steering control conditions. Oscillatory behavior is very important. What is this oscillatory behavior? So generally it is very important in that. Let us say I want to explain here. Let us say where passenger car is moving this direction. Passenger car is moving this direction. This is one of the direction, and second is having the roll condition. So vehicle is moving this way along the axis, unnecessary because of the road condition. Because of the road conditions are this rolling. This called as roll. This called as roll because vehicle is moving left and round, means rolling. This is rolling around the x-axis. Let us say this is a longitudinal axis, x-axis. Along the x-axis or longitudinal x-axis, we have the roll, and this roll is because of the road conditions, because of the independent rear suspensions, because of the change in center of gravity. When you change center of gravity also, when you change, let us say this is our center of gravity for a one vehicle. When you change the center of gravity, so we observe such type of rolling. And independent suspension systems. We have the independent suspension systems. Independent suspension systems. We have the road condition. This is a hole, a big hole on the road, and driver is just want to check the speed, and driver is controlling the vehicle because of this hole on the road. Now what will happen? The road, this tire will come in this hole, and this is the direction of because independent suspension system, this vehicle will move like this, and hence we have the rolling conditions. We have the rolling again. When vehicle will move, it becomes straight, and hence it is called as the rolling, and it is called as the oscillatory behavior of the vehicle. It can be controlled by three conditions because of CG, high CG, independent rear suspensions. It depends on road conditions, and hence lot of companies have developed this car sim program. We can control this by car sim program or simulation. Car sim simulation are used for this calculation of oscillatory behaviors. And this vehicle dynamics has different types of vehicle dynamics. Okay, so what is this vehicle dynamics? Vehicle dynamics has three classification. Longitudinal dynamics. Let us say this is a passenger car. This is passenger car. It is moving. So this is according to the length. According to the length, this is called as a longitudinal dynamics. Okay. So what are the changes? This is along the x. This is along the x. Let is this is the first. Now this we have to check all dynamics along the length, called as a longitudinal dynamics. We have to check the vehicle behavior in this direction, in along the x direction. Along the x direction, what are the vehicle behavior change? Now, what is the lateral dynamics? What is the lateral dynamics? So now this is a y. This is along the y. This is a y. Now this is a axis. This is the vehicle axis, which is vehicle axis along the y direction, and we have the vehicle behavior. We have the vehicle behavior that is called as lateral forces. Here, lateral forces. We'll discuss the lateral forces later on. We have different types of forces: lateral forces, longitudinal forces, vertical forces, like that. So lateral forces are available. When time permits me, I will explain the different types of lateral forces. We have the different types of lateral forces because of the lateral dynamics. So this is along the lateral dynamics, which is parallel to the ground and perpendicular to the x-axis. Now vertical dynamics. So this vertical dynamics is very vertical. So it is let us say this is a vertical dynamics x. This is x. This is let us say z. This is x. This is y. This is y. This is z. So this is the y, vertical dynamics. So vehicle behavior must be checked this, and hence we have two motion for this. We have two motion. We have two motion. One for this, 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 one for this. So lateral dynamics it has. We'll discuss in the second slides. Just to understand what is the lateral dynamics, it is along the y direction, which is parallel to the ground. Vertical dynamics can be obtained. So it is not a it is not obtained by the vehicle, but it is obtained by the road conditions. Because of the unnecessary vibrations are created on the vehicles because of the road conditions or insufficient suspension systems or insufficient tires absorbing conditions. So we have the vibrations. Because of that, we have different types of dynamics. We'll discuss different dynamic. I will come to the here three direction of motion. So generally, it has 6 degree of freedom. 6 degree of freedoms. We have the dynamics. Now this vehicle is moving in this direction. Along the x direction, we have this motion. This is called as roll. This is called as along the x-axis, vehicle will move along this. Vehicle move along this. This is called as rolling. Roll along the roll axis. Let us say this is roll axis. Along this roll axis, vehicle will move. Now this is a forces are created. The vertical. This is called as a lateral. So lateral dynamics will produce. So we have the axis. This is called as axis along the perpendicular to this and parallel to the ground. And we have the unnecessary motion. Motion. It is called as a pitch. It is called as a pitch along the y-axis. So now because of the vibration of the vehicle, it is moving. This vehicle is vibrating like this. Particularly during turning or during cornering, we require the yaw conditions. And hence along the x-axis we have 2 degrees. Along y-axis we have 2 degrees of freedom. Along z-axis we have 2 degrees of freedoms, and hence during considering design of vehicles we have 6 degree of freedoms, and we will have to calculate all 6 effects during this. We will discuss one by one. I will go to first longitudinal dynamics. So I will check what is the vehicle behavior in this direction. What is the vehicle behavior in this direction? Just to understand what is the vehicle behavior in this direction. Now this is very important. This is very important here. I have mentioned that is RFF and RFR, rolling resistance. We'll discuss the rolling resistance force. So rolling resistance force can be considered at front wheel, or it may be considered for rear wheel, or it must be considered for both wheels at a time. So means rear wheel drive it is different, for front wheel drive it is different, for four wheel drive it is different. I will consider here only four wheel drive. Now don't confuse here, because we have the different condition. Already I have explained rear wheel drive, front wheel drive, four wheel drive. And for the clarification of longitudinal dynamics, I have considered here four wheel drive, and hence I am taking the vehicle behavior along this direction only, along this direction. Now this is uphill. Now I want to check the forces when the vehicle is on the uphill. Now let us say this is a wheel, second wheel. I have mentioned the point A for this wheel, rear wheel. This is a rear wheel. This is called as rear wheel. This is the front wheel. This is the front of the wheel. This is the front of the wheel, front of the car. This is the rear of the car. Now let us say this is the reaction. This is the reaction on the tire, perpendicular to the tire. Now this is the load. This is the load, actual load on the vehicle. This is the load. This CG is very important for any calculation. The center of gravity of the vehicle is very important. Center of gravity depends on the total weight of the vehicles. Is it total weight of the vehicles? When this total weight, when it is on the ground, let us say this vehicle is on the ground. Now this is the position. It is directly acting on the ground, perpendicular to the ground. But in this case, this downward motion, that is the weight of the vehicle, are distributed in two conditions, that is W sin theta. Now this is the theta, this is theta, and we have the theta condition here. So which is forces along the parallel to the ground, that is called as W sin theta, and perpendicular to the ground, that is called as these are called as the resolution of the total weight, W cos theta. And hence we are using this is horizontal force, this is the vertical force. Now according to this total weight, according to this total weight, when these total weights are distributed along the two wheels, these two wheels equally. Now when it is acting on this, we have the reaction. This is called as a reaction, reaction because of the tire. This WF is the reaction at the front wheel, therefore I have written at WF. This is W, this is the W. I can say it is W by 2. I can say it is W by 2 like this, as it is the four wheel drive. Now WF is the total reaction because of this W. Now I will consider this W here for simplicity. WF is the reaction because of this tire. Now here also at the rear end, again at the contact period and the contact point, we have the WR, that is this. This is called as a FR. FR is the traction force. With this traction force is developed by the electric motor or IC engine can be developed. This torque. This torque is transmitted to the wheel, and hence at the wheel it is showing like this. And when it is acting on the ground, it becomes linear. So here it is. This torque is angular on the wheel, but when it is acting on the surfaces, therefore at the contact point, it becomes linear. Therefore it is the traction. Therefore it is called as a traction at the rear wheel. This is called as a traction at the front wheel. Now because of this traction and this is called as the rolling resistance. We'll discuss what is rolling resistance. This is the front rolling resistance. This rolling resistance is opposing traction. Now therefore this is because of this direction, traction direction is depending on the vehicle direction. This is the vehicle direction. This traction direction depends on the vehicle directions during a field. So field direction is this, and this rolling resist direction which opposes the traction. And similarly we have the front RFF. Here I have written RFF is the rolling resistance force at the front wheel. Here I have written RFR, rolling resistance force at the rear, like this. And this CG location is very important. I am calculating CG location. Now this is very important. H. From the ground, I have count H. Small h is the CG location from the ground. Now this is the RA. This is RA. These are the all forces acting on the wheel. This is RA is the aerodynamic force, external force which is acting on the front surface. RA. So RA, that is the centralized RA. We have so many. So this is called as the center point. This is called as the center point for all aerodynamic force. So let us say this is the center of the RA. Now the center of the RA is considered away from the ground. It is denoted as HA. Now what is the next force? This is RD. This RD is very important. That is this is very required to calculate the total traction force which is required for the vehicle. Let us say this RD. Suppose another car you have attached, another car or trolley you have attached, another car. This is another car. Suppose you have attached the another car, means during towing. Now this is your own car, and we want to tow any car, another car, and hence another force is required, and this force is required. Otherwise, vehicle will not carry this load, unwanted load, and hence engines and as well as electric vehicles are designed to compensate this additional, and hence it is very important to calculate the RD. Otherwise, you cannot tow the vehicle. If vehicles are engines are designed or electric motors are designed for this only our vehicles, then we cannot tow any type of vehicles, and this is RD, that is a force which is developing by the car. It is in this direction, and we have to concentrate in this. Now this is the direction, it opposite direction, and what is the concentration of this HD? Height of the RD, that is the resistance because of the trolley or the car. This is now this we have so many forces. D Albert's force we have. Now this is F. This is actual F. MA. This is the actual F we are generating there. Because of this F, vehicle will move. So these are the forces, actual forces on the vehicle. You must understand all forces which are acting on the vehicle during vehicle dynamics, and because of this vehicle dynamics we have to design the vehicle. What is the engine type, what is the electric motor type, what is the layout of the car, what is the layout of the axles, what is the wheel base, what is the wheel track, what is the size of the chassis, what is the frame. So all we require, and hence we have to consider the aerodynamic force, gravitational force, drawbar pull. So what is that is called as a drawbar pull. Okay, when you apply the car, that is called as a drawbar pull. Okay, car is a drawbar pull. Now this traction force, that is the basic requirement for acceleration. Why we require the traction? For acceleration. For acceleration we want the electric motor. For acceleration we want the electric motor. What type of torque can be generated by the electric motor for the vehicle dynamics, and hence this vehicle torque can be calculated, and it is calculated for the electric motors. For four-wheel drive, it is torque is different. For rear-wheel drive, the torque is different. For front-wheel drive, torque is different, and hence traction force which is transmitted from electric motor to the wheel by driving or driving components. That is called as a driving gears. So braking force are very important. It is called as the rolling resistance of the tire. This force opposes the traction force. It acts opposite to the tractive force, and hence what is why we require the fuels to consume. Now 30% fuel is consumed because of this rolling resistance. Now we have the reactions. at the wheels. Already I have explained this reaction as WF and WR. This is called as the D'Alembert force. D'Alembert force. D'Alembert force is the hypothetical force which is opposing to the action of the vehicle. That is a force which is required to drive the vehicle. So that is called as W by G into G. So this is very important, which is opposing this W by G by A. So now this is a hypothetical force. Now this propulsive force is developing by the engine or electric motor. This is generally a propulsion force is very important, because it is actual force which is available at the tire. So this height must be designed. This already I have discussed. So generally for passenger car, this is generally for passenger car. During design of this, we are considering HA equal to HD equal to H, like this. This is very important. But in other cases, buses or trucks, these are not important. And calculations. So this is very important. What is the L1? That is the L1. I showed the directions. That is L1, L2, like this. When you say this is L1, so this is the L1. This is the reaction force from the center of gravity. This is the reaction force from the center of gravity, from the this rear wheel, from the front wheel. And what is the total length? Total length, that is called as a wheelbase. This is L1 plus L2. So just you observe that this L1 plus L2 is very important. That is the wheelbase. So during this design of this vehicle, wheelbase is always important for vehicle dynamics. So now I am not calculating here reactions that will you try at your home. How these reactions are calculated by taking moment at point B as well as point A. You take the moments, you will get the calculations. Now during when you take the field directions, we are getting the equations, horizontal equations like this: F equal to MA, MF, FR minus RA minus RR, W sin theta, RD, like this. So this is now I have given this for a field. I have given this for a field. Now when you apply this for downhill, now let us say a vehicle is moving from wheel and the vehicle direction is like this. We cannot apply this equation. Always remember, we cannot apply this equation directly. So you have to find out the special equation for downhill direction. Similarly, we cannot apply same equations. We are getting different equation when the vehicle is on the road. So therefore, we understand the equilibrium forces. Equilibrium forces are very important for design of vehicle dynamics, and hence calculations of these reactions. Already I have explained the yaw, roll, pitch. So these three are very important. 6 degree of freedoms we have today. So direction of motions, already I have explained this. What is the longitudinal direction? What is lateral directions? What is vertical directions? Angular motions. These are the angular motions. Roll is the angular motion along the x-axis. Pitch is the angular motion along y-axis. Yaw is the angular motion along z direction. Already I have explained. Now we have to understand what is. So shall I continue, sir? Hello.
Yes, sir. It's 1:33. Hello.
Shall I continue?
Yeah,
Shall I continue for
you
review?
can continue. For yes, sir. You can.
I require 5 minutes. Just I require
5
5
minutes.
minutes.
Sure. No problem, sir.
Okay. So generally, when we want vehicle dynamics conditions, so what do you mean by vehicle dynamics condition? Generally, vehicle dynamics conditions depends on forces acting on it, and hence why we want vehicle forces, because of the vehicle movement. So generally, our vehicle is design is depends on vehicle movement, and hence we have designer must know what are the general description for this vehicle movement. So just design, just I have given, I have, because of time limit, I will not explain everything. This already, I have given this figure. So a figure is very important. You must draw the figure, whether it is on a field direction, whether it is on downhill direction, whether it is on ground conditions. So every time forces are different. For a calculation of these forces, on the tires, so and the wheels, you must know what is the propel conditions. On that condition, from the tractive effort, you are able to design the electric motor. You are designing the electric motor or engine. Otherwise, vehicle will move not forward. This is very important. Vehicle forward. Vehicle forward is very important. Otherwise, if electric vehicle traction is not equivalent to the vehicle traction, vehicle will not move. So that is called as tractive effort. So to give the tractive effort, that quality of the electric vehicle as well as electric motor you have to develop. In case of engine, we want that type of engine. That is called as a tractive effort developed by. That's why we are calculating in case of IC engines, we are calculating brake power. Brake power is transmitted to. Otherwise, it is very difficult to understand in case of electric vehicle, electric motor. So, what is electric motor torque? Torque at the shaft of the vehicle, shaft of the motor. So that torque at the shaft we have to develop the torque. This torque is transmitted to the wheel, and hence tractive effort. It is very important. So for power plant torque means that is electric motor or engine torque which is transmitted to final drive. So final drive must be designed. Vehicle means different types of forces we have. So otherwise the vehicle will stop. If the frictions are developed more than the tractive force, vehicle will stop. So generally more resistances are included. Rolling resistance. What are the different types of resistances we have? Rolling resistances, aerodynamic resistances, field resistances, that is called as grade resistance. And we have the different types of tractive forces, or let us say we have front wheel drive. So tractive force is different for front wheel drive. Rear wheel drive, we have the different types of force. For four wheel drive, we have the different types of tractive force. And hence we have to do the summation of it. What is the total force required for each type of vehicle, and that type of motor can be used. Otherwise, motor is not sufficient to develop that torque which is required to run the vehicle. And hence, this vehicle speed is very important for the vehicle motion. Otherwise, this motion, why we get the vehicle speed? Because of the transmission of power from the electric motor to the wheel. If the motor is not sufficient to generate the torque, that much torque, we can generate the vehicle speed. That V is very important. Speed and acceleration. Speed and acceleration is very important according to the driver. So always we are designing the car for the different types of speed. That's why we are giving the more and more acceleration. And this acceleration depends on three conditions. What is my tractive effort? What is my tractive effort? This tractive effort is generated by the electric motor. This tractive effort. And hence when I want speed or when I want acceleration, I want to go for tractive effort generated by the electric motor. What type of electric motor I want, and what type of resistances. If the road condition is very more, resistances are more, then I want, I don't know what the road conditions. If the road condition is very hard, but I have not considered during that, but electric motor is not sufficient to drive, the vehicle will stop for the road conditions. The vehicle mass. So this vehicle mass is very important during design of this electric motor. During design of vehicle motor. Let us say we want to design the, let us say this is a truck. This is a truck. This is a unloaded truck, and we are using the electric motor for that. So a vehicle will move. Vehicle will move because of this torque developed by the electric motor. But when it is loaded, and that type of torque, this type of torque we require at the wheel. We require this type of torque at the wheel. Whether this torque is sufficiently developed by the electric motor, you have to check. This is very important. Now, rolling resistance we have to develop. What is meant by rolling resistance? This rolling resistance is a drag force because of the particularly observed by the road condition, aerodynamic conditions. Other than aerodynamic conditions, the resistance because of the tire only. We are considered, as we will discuss different factors to be considered. This rolling resistance is very important, and this rolling resistance may be developed only because of the tire. only because of the tire and what type of tire we require, and hence we require some conditions of the tire. Tire deflection is depending. Otherwise, this is a round tire. When it touches to the road condition, it becomes like this. It becomes flat. At the road condition, it becomes flat. So this is the condition, deflection. It called as deflection. And as the load increases, deflection increases, and hence tire deflection is very important. So how much deflections we have in the tire and rolling resistance, as tire deflection increases, rolling resistance deflection increases. Tire temperature is very important because we are measuring the temperature of the air which is available inside the tire at the cold condition. Then this is the manufacturer instructions. Always you have to measure the air temperature at the cold conditions. When the air is hot in the tire, it is not measured, temperature is not measured, and hence the condition of air, cold condition and hot condition of the air is totally different, and hence we have tire temperature is very important. Inflation pressure inside the tire, is called as and this inflation pressure is decided by the manufacturer. Let us say this CR tire has a different pressure, JK tire has different pressure, and hence as per the instructions of the manufacturer of the tires, we have to keep the inflation pressure. Vehicle speed, according to the tire conditions, we have to do the vehicle speed. Trade condition, trade is generally now what is trade? Trade is here. Trade, I will explain the trade. This is called as a trade. This is a trade. And hence trade conditions. Trade conditions we have. Trade thickness. This is called as trade thickness. This trade thickness we have to decide. This is called as a trade thickness. We'll discuss later on what is trade thickness, why it is required. Now, just to understand trade thickness, number of filers during design of tires. I will not go to the number of filers, but we have the number of stages of the tire. We have number of filers, rubber conditions. The quality of the rubber is very important. Already we have discussed that elastomer tire is where we are preferring nowadays. It has elastic condition as well as viscous conditions, and hence in modern tires we have elastic condition and viscous tires also. Level of torque transmitted by the tire. So this tire, now this electric motor torque is transmitted to the tire. This is the tire wheel. This is the tire. Now this is the tire torque. This is the tire torque we is developing by the this tire torque developing by the axle, which is obtained from the electric motor. This level of torque we must know for the speed of the vehicle. Nature of the road surface. For the rough surface, it is different. From the plain surface, it is different. Tar road, it is different. For cement road, it is different. Types of tire. So whether it is pneumatic, जिसमें हवा होती है, that is pneumatic tire. So air contains. Now solid rubber tire, only it is made of rubber. It is called as now we are not considering in this case. I am not, nobody can consider the solid rubber tire. We are considering only pneumatic tire for passenger and trucks, buses. Weight of the vehicle is very, very important. According to the weight of the vehicle, because the truck tire is not suitable for passenger car, or passenger car tire is not suitable for the truck. So why? What is now you ask these two questions? What is rolling resistance? Why tire is developing rolling resistance? Now generally people are asking, sir, rolling resistance is a frictional resistance. Don't remember or don't say that rolling resistance is a frictional resistance. Rolling resistance is developed by the tire conditions and road conditions, and how this tire is acting on the road, that is the rolling resistance. Always remember, we will discuss. And this rolling tire condition is obtained by the property of the rubber which we are using for manufacturing of this. What is the type of rubber we are using for the manufacturing of the tire, and because of the manufacturing of the tire we are getting the rolling resistance. So don't think about that it is a frictional resistance. So and hence when you want, always there is a research on this tire. when you want to do the PhD, now we have the design of tire on rolling resistance, how to reduce the rolling resistance. What is the problem of this tire? The rolling resistance of the tire consumes 30% of the fuel of the vehicles. Okay, when you say that is 1 liter for that kilometer, it means that only tire is consuming 30% of the fuel. Engine is not consuming. Let us say when we want 100% fuel, then only 70% fuel is given to the engine or electric vehicle, 30% to the rolling resistance, and hence tires of vehicle are produced with the minimum rolling resistance. Okay, and hence how these elastomers, now elastomers are the very proper material. Now it has two property, one is elastic properties, second is a viscous property. Now I will explain. This is very important. Let us say this is a truck tire. This is a truck tire. I want to explain. This is a truck tire. Now this truck tire has a tread like this tread. Now when the treads are touching to the surface, now the tires treads are touching to the surface, it is called as a contact patch. This is called as a contact patch. Now this contact patch, now this surface is very important from the vehicle dynamics point of view. Now this is the actual portion which is touching to the surface, and this portion is supporting to the load. Now this is the load to the vehicle. This is load to the vehicle. Now this is the surface. This is the surface called as a contact patch of the tire, which supports the load W of the vehicle, and during rotation, now this is the rotation of the tire torque, because of the torque given to the driving wheel, we have the now this is for when this thread, now this thread is touching to the ground. Now there is a compression of the thread. There is a compression of the thread, and when it is leaving, now this thread is leaving. This thread is leaving to the ground, and this is called as a compression region. Now this is called as for this we have the compression added. For this we have the compression region, and we have the two mechanism: compression addition, compression region. And during that period we have the opposite torque to adjust this. We will discuss how this opposite torque is developing by the tire to adjust this load. Let us say how this contact patch for stationary tire. Now the stationary tire condition is different, motion tire condition is different. For now I am giving the condition. What is meant by good vehicle tire? What is meant by good vehicle tire? When contact pressure is equal to inflation pressure. Okay, then tire is stationary very easily. Contact pressure equal to if there is a inflation pressure, हम बोलते हैं कि नहीं हवा कम है. This is very tendency. That's why we are checking the pressure, inflation pressure every week. And whenever there is a inflation pressure, this contact patch will increase, and hence we have the many disadvantages. I will not go to the detail of the inflation pressure or contact pressure in detail, but I am going to the detail of generation of the rolling pressure because of the tire. So generally, why we are using the 32 psi for the car, and why we are requiring 100 psi. Now this contact patch is very important. This contact patch, this is the contact patch for this. Now there is a development of the pressure. This is called as a pressure diagram. This is called as a pressure diagram. Now I have given a pressure distribution diagram. So whenever the center of the contact patch is acting maximum compression. At the center we have the very maximum compression. So this means this portion is absorbing actual load of the vehicle when it is stationary, and pressure is distributed at the contact patch. It is balanced by the inflation pressure. If inflation pressure, now this inflation pressure is concentrative inflation pressure, and it is contact pressure. It is contact pressure. Now this is very, otherwise a vehicle will not move very easily, and this contact pressure you have to maintain. Now just to observe the condition. Now you observe the condition, vehicle is moving, tire is moving, tire is moving. We have the reaction force for moving condition. We have, now this is the torque. Because of this torque, because of the rotating torque which is developed at the wheel, now it is developed at the tire. Because of that, tire is moving. Now this is the reaction force opposing the acting on opposite to the load. Now this is the ground, at the ground. Now this is the traction force. Now this is the torque. Now this is the angular torque. This angular torque, when touches to the ground, it becomes linear torque. It is called as a traction force. When it is touching to the surface, it is called as the traction force. Okay, it is a force. It is a torque. It is different. And this rolling torque or traction force is giving motion to the vehicle. Now, because of this rolling torque, we have the rolling force which is opposing to the traction force, and that's why vehicle speed is reduced. And this is actual load on the, as the load is increasing, this reaction force is changing, and hence because of this load, reaction force increases. Because of this reaction force, traction force is increases. Because of this traction force, rolling resistance increases, and therefore vehicle speed will reduce. This is the mechanism of transmission of force with respect to the load of the vehicle. Therefore, load of the vehicle is decided according to the torque available at the wheel, and hence we will discuss about how this is developed. Now this is condition, effects of inflation pressure on the tire. Effects of inflation pressure. Now this is the contact patch. Just I am assuming this is one trade. This is one trade. This is the center of trade. Here at the center of trade, we are inflation pressure is acting. At the center of this opposite, that is the contact pressure is acting. Now contact pressure is full. Where contact pressure is equivalent to this, we are calling when it is full contact. Contact pressure is when it is full contact. When inflation pressure equal to the contact pressure, then this contact contact patch is very accurate, and this is called as sometimes it is called as a block. This block is having this area, lesser the area, lesser the rolling friction, lesser the friction means low maximum speed. Maximum speed means higher lower consumption of the fuel. This is the relation of the mechanism of the tire, and hence what is important here, and hence contact pressure we are assuming theoretically contact pressure is very equal theoretically, but it is not like that. Contact pressure should be uniform, but practically it is totally different. We'll discuss later on in practical condition. When the vehicle is stationary, contact pressure equal to inflation pressure, but during motion condition, practically contact pressure never be equivalent to the inflation pressure. Therefore, effects of inflation pressure. Now, why we require the inflation pressure means गाड़ी में हवा क्यों चाहिए, ऐसा अगर आपको क्वेश्चन पूछते, because to now this is the main motto of this vehicle dynamics, where when we want safer condition for the vehicle, and hence we are using the air, that is the pressure of the air inside the tire. Safe use of tires. Inflation pressure always plays an important role in carrying the vehicle load. If the pressure is reduced and you are increasing the vehicle load, safety is reduced. Under inflation, over inflation is creating lot of problems. If it is under, it is problem. Over inflation, bursting of tire is a very accident takes place because of over inflation. Now this is very important. Why tire fails? Because of under inflation or over inflations, or it is unsafe. Don't estimate the tire condition. It should be exact inflation pressure you are using. Don't use under inflation pressure. Don't use over inflation pressure in the tire. And hence the right amount of air for tires, for your tires, is specified by the vehicle manufacturer. And hence according to the vehicle manufacturer, just you read the brochure of the vehicle manufacturer. It is given in that what is the tire pressure, and you feel the air pressure in that to maintain the vehicle dynamics very properly. Don't measure the pressure when the air is hot in the tire. Always you measure the pressure in cold condition. That gives the accurate tire pressure and accurate tire temperatures. Now what is the change? Just you observe that what will happen Now already we have discussed. This is very important. This is the earlier case. This is the earlier case. This I have given. This is the contact pressure diagram. This is the distribution of pressure. Here is the maximum load. But in reality, it is different. In reality, it is different. But when just I have written during loading and unloading of trade, that is during torque. You are mentioning here torque. Torque is added during running condition. Because of that, what will assume that compression is more in this case. During addition of compression, we require the more trace. During addition of compression during initial condition, we require more stress, and it releases, compression releases, and stress is releases, and this diagram will change. This diagram will change, and hence this total load. This is RF. This is RF at the during motion. We have the difference. We have the difference in the running condition. This is the center point of RF. This is the during running condition, and this is the stationary conditions. But we have assumed that we have assumed this condition here, and we are getting the distance here. We are getting this distance is making. Now this RF is giving the couple to the. Now this is the couple. Now when moment is created, moment that is a torque is created, we are calling that couple. This couple is created at the center of the contact patch, and this RF into this distance creating couple, and this couple is nothing but a force. This couple is when it is giving linearly, it becomes force, and this is a couple. Now this is the torque developed by the tire. Now this is the torque, that is called as couple, developed by the change of position of RF, and hence because of this RF, now this is unnecessary force we are creating there, and to adjust this load, that is RF, we require the extra power. We require the extra power to consume this. Now some power is consumed to adjust the load, and hence it is very important. Therefore, I have written here different couple. Now according this couple is generating depending on the yes.
Sir,
Yes.
sorry to disrupt. It's already 2 o'clock because next session is also scheduled. How much time will require, sir?
I will explain only one slide.
Okay. Thank you.
Okay. So now because this is very important for vehicle dynamics. Now this hysteresis loss. So tire selection is very important. Tire selection is very important. When you select the elastic material, ordinary material for tire, and during testing of tire, when you plot along the y-direction trace versus, that is load, trace versus strain, what will happen? What will happen during loading? During loading, we are getting this graph. During unloading, we are getting the same graph. Means there is no change. During same trace is absorbed, but for viscoelastic material, now during loading, there is I have written here compression of trade. The trade is compressing. This trade is compressing during loading condition, and this is now this is the direction I have shown. And again, that trade comes releases its energy during direction, and during this it is releasing. Just you observe that I have given during unloading or relaxation of trade. Now just you observe that when I draw, this is the diagram of for stress versus strain. Okay, stress versus strain. Just you observe that for same strain, we require the more stress for during loading of trade. For same strain during unloading, we have the energy. And when this is the called as this diagram we obtained is called as a hysteresis loss. What is this hysteresis loss? This is actually loss which is occurred by the tire, and this power, this loss, we have to consume somewhere. We have to compensate this loss, and this loss should be compensated by the electric motor or by the electric engine, and hence we are consuming 30% of the fuel because of this hysteresis loss, and hence so just you assume always when you teach as a faculty, we have very important two components in the vehicle. We have the tire, which has various different types of forces acting during stationary condition, during moving conditions. Similarly, when you want to design of IC engines, the piston rings having different motions during different strokes, and these are the designed very carefully. In case of design of engine, piston rings are designed very carefully. During design of engine, vehicle, the vehicle tires must be designed very carefully. So because of time, I cannot explain it properly. It has so many tires. So thank you very much. If you have any questions, you can ask.
Yes, sir. Thank you, sir. Participants can either ask the question through the chat box or just press the raise hand button so that I can unmute them. Hello, sir. There is one question. Why all speed breakers are of convex shape? Means, is there any effect of concave shape or digs on vehicle dynamics?
So it depends, bumping. So bumping is very important for vehicle. That is, yaw is created in the vehicle, and particularly during turning or during cornering or during speed breaker, we have the unnecessary these conditions we have obtained. That is yaw. That is called as bumping, and bumping is not suitable. And we are applying the brakes during that. As the height of the speed breaker increases, it is very dangerous for the vehicle. It gives otherwise you have to deaccelerate vehicle suddenly, or if when the brake is not applied, we have the more bumping of the vehicles, and driver may lose the control of the vehicles. Okay, directional stability. Already I have explained that driver direction stability is very important, and during design of vehicle, loss of directional control is very important. So because of time factor, I have not considered the loss of directional control. So this loss of directional control is very important during design of the speed breaker. So as a driver, just you are the driver, do you feel that speed breaker is desirable? So tell me this answer.
No, sir. That actually it will never be desirable.
It will never be, because otherwise you have to reduce the speed. If you have a vehicle speed is 120, that's why we are designing this highway, no? So there is no speed breaker in the highway. Otherwise you are deaccelerating the vehicle. You are applying the unnecessary speed. Otherwise, if you are applying more height of the speed breaker, what we have, if by chance you have not applied the brake, what is the condition of the vehicle? Tell me, what is the condition of the vehicle? It is bumping is more, no?
Yes,
bumping
sir.
is more. Can you say that the passengers are safe in that condition?
No.
Can you? So, do you the feeling of the passenger is changed suddenly? जर मराठीमध्ये तुम्ही असाल तर मी बरेच पॅसेंजर ड्रायव्हरवर रागवतात बऱ्याचदा. when the driver is bऱ्याचदा when the driver is applying sudden loads, he is not observing the speed breaker, and he generally when he touches the speed breaker, suddenly he applied the 100% brake. What will happen? All the passenger come forward. And this is the passenger condition. And what is the vehicle condition? What is the vehicle condition? The tires are not touching to the surfaces. Tires are not touching to the surfaces, and vehicle loses its control. And now, why? When you are applying force, when the tire is touching to the surface. Okay. So unnecessary yaw is created, means unnecessary 6 degree of freedom is there. During bumping, that is called as vertical vibration. That is called as vertical vibration. We don't have control on the vehicles. Yes, am I correct, sir?
Right, sir. Very right.
So it is having Dilip study given me some hints of this. He taught me for 5 days, even though the complete vehicle dynamics is not completed. And in 1 or 2 hours, it is very difficult to control the vehicles. I have not controlled I have not given the suspension system, steering system. Only I have given the only tire manufacturing, tire mechanism only. Basic of 6 degree of freedoms: longitudinal directions, lateral direction, vertical directions, and lateral forces are also developed. And I have not explained to you. So during conditions, cornering, what will happen? During stopping of the vehicle, what will happen? During good condition of road, what will happen? Like that. So any other questions?
No, sir. Nobody has put up.
So
Yeah.
if you have any
Hand
doubt,
raised.
if you have any idea, questions, so I have my email ID. I will give the answer for it. So are you satisfied with my lecture? Because of this, I have not connected with the basics of tires, that is a camber, wheel plane, turning
You
moments.
covered some important aspects of the vehicle dynamics. And yes, definitely, entire course cannot be covered in 1.5 hour session. Actually, you took a very long session, so lots of things were covered. And I feel if any question is there, I'll take from the participants and definitely forward it to you.
So actually, sir, what will happen? Mixed participants are there in generally. If I go to directly the mechanism and equations, many participants will not understand.
From electrical department are more. Then mechanical are there. People from management side, people from agricultural side, they are attending this because this is a very common topic of interest for everybody.
Yes, sir.
Yes, sir. So, sir, shall I wind up this session for
yes, sir.
Yeah.
Yes, sir. Yes, sir.
Okay.
Thank you very much for giving me chance.
I'll just give one message.
I have delivered so many lectures in different FDPs on different areas. My area is not fixed. Particularly,
Correct,
I am concentrating on IC engines, combustion system in IC engines, because many unknown things are. Particularly, I have started my work for BS6 engines. So now from 1st April 2020, government is concentrating on BS6 engines. So what are the modifications for BS6 engines? We must understand. Common people are not knowing the rules, then fuel consumptions for that, rules of NOx, rules of this, components. So vehicle dynamics is particularly for vehicles. Okay.
Sir.
Okay,
Sir,
sir.
on behalf of Father Robotics Institute of Technology, Department of Mechanical Engineering, I would like to thank you, sir, for sparing your time and being present over here to deliver the lecture. Thank you very much, sir. We'll keep in touch in case in future if we require your interactions. I hope you'll agree for that as you agreed this time, sir. Okay. Thank you, sir.
Thank you very much.
For participants, the feedback link has been posted on WhatsApp group and the next session will start at 2:30. Thank you all very much.
Thank you very much, sir.
Thank you.